So parts, so first of all, what is a polynomial? Polynomial's got all these parts here. Okay, it's got all these parts here. It's got something called coefficient. Coefficient is a number in front of a letter. A number in front of a letter. Okay, so negative 2 is not a coefficient. It's got a different name. It's called a constant because it doesn't have a letter. Okay? Exponent, you guys know what an exponent is. Okay, so terms. There are 3 terms here. This is a special type of polynomial. It's called a trinomial because it's got 3 terms. 4x to the third power, 5x squared, negative 2. It's got 3 terms, okay? Variable, you guys know what variable is. Leading term, okay, so this is the big one here, leading term, because they're gonna ask you for a leading term. Leading term is the term that has the highest power, okay? X to the third is the highest power. That's why this guy is the leading term, okay? So the leading term is the guy that has the biggest power. Who has the biggest power? This guy here, 4x to the third. That's the leading term, okay? Because they'll ask you, what's the leading term? Sometimes it's not in order. Sometimes this part will be at the end, okay? Hey. Sometimes it'll be like this. There's 3 terms. Which one is the leading term? 8. The one with the 8, yeah, the one with the 8. This guy's the leading term. But you're like, it's coming in, it's in the very end. Why is it a leading term? Because it has the biggest power. Okay, because it has the biggest power. Okay? So just be careful with that sometimes. Okay? Degree means it has the biggest power. What's the biggest power? Okay? Leading coefficient. So sometimes they'll ask you for things like leading term and leading coefficient. So we said the leading term is the one in yellow. What's the leading coefficient? The leading term is in yellow, 8x to the fourth, right? Well, now I switched out term with coefficient. So what would be the leading coefficient? I thought I heard it somewhere. 8. So the leading term is that. The leading coefficient is just 8. Because what is a coefficient? A coefficient is just a number in front of a letter. Well, the leading, we talked about, was this guy. The coefficient is just the number. Okay, it's just the number. Okay? Okay, so degrees. The degrees are the highest power, right? Like this guy here is a cubic because the highest power is 3, right? So if the highest power is 3, it's called a cubic. Last chapter, the highest power was 2. If the highest power is 2, it's called a quadratic. That's the thing we just took a quiz on last week. Quadratic. That word was all over the notes from last chapter. Quadratic. If the leading term is 1, it's linear, a line. If the leading term is 0, it's a constant. It means it doesn't have a variable, like 2, like negative 2. Negative 2 doesn't have a variable, so that means its degree is 0. Okay? Okay, 4. 4 is called quartic. Quartic. And 5 is called quintic. So the ones we're going to deal with this chapter, really all of them, but the ones we're going to focus on are these guys in pink. Those are the ones we're going to focus on in this chapter. Okay? We did number 2 already. We did quadratics already. That's what we did last chapter. But this chapter is, we're going to focus on the rest of them. Okay? All right, so now do a matching game, a matching. So what I want you to do is, these are all the words that we talked about, a few extras that you might have heard of. So I want you to match which one goes in which one. Okay? Try it, see what you get. We'll go over it in a few minutes. All right? You can only use each letter once. Only use each letter once. So you can't have any repeats. Okay? So which one does A fall under? Which one is B? Which one is C? Which one is D? So on and so forth. All right? So coefficient, negative 2x minus 7a, that doesn't refer, that's 2 terms, right? 5x is 1 term. 1, 2, 3, 4 terms. C is 4 terms. So we want the number in front of a letter. So let's go down, let's see, E. The 7 and 7x plus 2. So just the 7. If I focus on just the 7, that's a number in front of a letter, right? So that's a coefficient. But then I see the one under is a leading coefficient. So I want to distinguish the two. So it has to be a coefficient, but not a leading coefficient. 7 is a leading coefficient. Okay? So that one's going to go there. So E is going to go there. Okay? And then negative 5, that's also a coefficient, but it's not leading. 8 is the leading coefficient. So that one, F, I think would be a better coefficient. Okay? Constant. Constant is just a number, no letter. The 9 and 6x squared plus 4x plus 9. The 9 has no letter. So that's a constant. Monomial. Monomial. Monomial means 1. Mono means 1. So 1 term. Just 1 term. That's where 5x comes from. 5x is just 1 term. So that's B. Binomial means 2 terms. Binomial. Negative 2x minus 7. A. Trinomial means 3 terms. Negative 3x squared plus 6x minus 9. That's 3 terms. So that is D. Polynomial. Polynomial is just, polynomials kind of catch-all. Like these are all polynomials, but polynomial is like calling you a human, right? We're all humans, right? It's just a very big term to like get to, it's a very big term with a lot of different components, right? Like even though we're all different, we're all humans. So if I just called you human, that wouldn't be wrong, but it's very broad. It's not very specific, right? Monomial is specific. Binomial is specific. Trinomial is specific. Polynomial is like the big term, right? That is C. Okay, that's C. All right. So the first part is just vocabulary. What do the words mean? What is coefficient? What's the difference between a regular coefficient and a leading coefficient? What's a constant? What's a monomial, binomial, trinomial, polynomial? Okay? Okay, so now the back side. Let's go to the back. So now we get into the adding, subtracting, multiplying. Adding, subtracting, multiplying. So I have a trinomial minus another trinomial. So the first thing you're going to do before you add or subtract is get rid of the parentheses. Okay? How do I get rid of these parentheses? What am I going to do to get rid of these parentheses? Because I can't Inside the parentheses, there's no like terms, right? They're all the same. Or sorry, they're all different. X squared, X, no X. So I can't add or subtract them. But how do I get rid of the parentheses so that they're free from them? Starts with a D. How do I get rid of parentheses? Starts with a D. Not to fit, you're close. Distribute, right? What's in front of the parentheses that I don't write? A 1. So, to get rid of those parentheses, I have to distribute a 1. Okay? So when you distribute, what operation are you doing? Are you adding, subtracting, multiplying, or dividing? Multiplying. Distribution is multiplying, right? So anytime I do this, it's just multiplication. So 1 times negative 3 is negative 3x squared. 1 times negative 9x is negative 9x. 1 times 5 is positive 5. Parentheses gone. Seems like an easy thing to do, but it is important. Okay? Now let's go to the other guys. How do I get rid of these parentheses? The same way, right? What am I going to distribute here? Negative 1. Not a positive 1. I'm going to distribute a negative 1. So when I distribute a negative 1, that's going to change the sign. Negative 1 times negative 2 is positive 2. X squared. Negative 1 times negative 4 is positive 4x. Negative 1 times positive 7, negative 7. No more parentheses. Combine like terms. Okay? Well, I do have some like terms. X squared and x squared. Those are both like terms because they both have an x squared. So I add their coefficients. Negative 3 plus 2, negative 1, x squared. Done. X, negative 9x, positive 4x. Add those coefficients, negative 5x minus 5x. Last guys, positive 5, negative 7, negative 2. No more like terms, you're done. Get rid of parentheses, combine like terms. Okay, not too bad. No, the negative 1 in the front, you mean? No, yeah. Yeah, so you could just, this guy, just as long as you have a negative in front, you don't have to put the negative 1 now. Okay? All right, so let's try this one. First step is always going to be get rid of the parentheses. If there are parentheses, we need to get rid of them. Well, we just did that, right? How are we going to get rid of these parentheses? Same way, right? Multiply. Just because there's something different in front at x squared doesn't mean we change the rules, right? So let's see. We're going to distribute. So the way to, sometimes it's easier when you distribute like this, sometimes it's easier to create what I call a multiplication box. Sometimes you don't need to, sometimes you can't. A multiplication box is a box that we use to multiply. So how many terms are in the front? 1. How many terms are on the inside? 2. So what I'm going to do is I'm going to create a box that has one side on the side and 2 there. X squared is going to go here. Negative 10x squared and positive 1 go here. And then it's just like multiplication. It's multiplication. So what's in front of the x squared that we don't write? Well, 1. So the first thing you got to do is multiply the numbers. Multiply the numbers. 1 times negative 10, negative 10. X squared times x squared. When you're multiplying powers, what do you do with them? Add, subtract, multiply, or divide? You add them. You add the powers. X squared plus x squared, x to the 4th. Done with that one. 1 times 1, positive 1. Only an x squared. Okay? Once you filled in all your boxes, you move them out. So we got negative 10x to the 4th and positive 1x squared. Can we add those together? Can I add negative 10 and 1? Are they like terms? No. One has an x to the 4th, one has an x squared. They are not like terms. We're done. If they're not like terms, you can't add them or subtract them, you're done. Okay? All right, let's go down to number 3. This one's a little different. First of all, I'm multiplying a binomial times a trinomial. Okay, how do I know it's multiplication? Because there's nothing in here. There's nothing on the inside, or between them, sorry. There's nothing here. If there was addition, we'd be adding them. If there was subtraction, we'd be subtracting them. But there's nothing there. So if there's nothing there, it means multiplication. Okay? So how do I multiply a binomial times a trinomial? The same way you just did a monomial times a binomial. Make a table. Make a table. Well, this one's got 2 terms. This guy's got 2 terms, right? And this guy has 3 terms. Right? So that means I need a 2 by 3 box. A 2 by 3 box. So I'm going to make a box that has 2 on one side, 3 on the other. So this side's going to have 2, and this side's going to be cut in thirds. So the guy with 2 terms is going to go on the left. The guy with 3 terms is going to go on top. Multiply. Okay. 3 times 3 is 9. X to the second power, x to the first power. Add their powers, you get x to the third. 4 times 3 is 12. Add their powers, x to the first plus x to the first makes x to the second. 6 times 3 is 18. X. 3 times negative 1 is negative 3x squared. 4 times negative 1 is negative 4x. 6 times negative 1 is negative 6 with no powers. Multiplication is done. What do I have to do left? Combine any like terms. Are there any guys in the box that are like terms? There are. This guy and this guy, and this guy and this guy. So I'm going to add the two pinks, add the two reds, and you're done. Be careful, when you add them, the powers don't change. So 9x to the third is going to stay 9x to the third. When I add 12x squared and negative 3x squared, the x squareds aren't going to add, just the numbers in front. So 12 plus a negative 9, or negative 3 is positive 9. 18 plus negative 4 is positive 14. Negative 6. Done. Okay. So look at number 4. What type of box are we going to need for number 4? A 3 by 3. So build a 3 by 3. Yep, you're going to need a 3 by 3 box for number 4. So build it and do it. So yeah, great question. Does it matter which one we go first? Because I know we have 3 terms and 3 terms. Does it matter which one goes on the side, and does it matter which one goes on top? No. Does not matter because you're multiplying. Doesn't matter which one you put first and which one you put second. So it's totally up to you. Because you're going to get, even if you have swapped them, you're going to get the same stuff on the inside. Your 9 boxes are going to look like my 9 boxes. They're just going to be in different spots. Okay? All right, so 4 times 1 is 4. X squared plus, or x squared times x squared is x to the 4th. So you should have a 4x to the 4th box somewhere. Okay? 4 times negative 3 is negative 12, x to the 3rd. So you should have an x to the negative 12x to the 3rd box somewhere. 16x squared. 7x to the 3rd. Negative 21x squared. 28x. 3x squared. Negative 9x, positive 12. Okay. Combine any like terms. So I'm going to circle the ones that have like terms. Well, this guy here and this guy here have x to the 3rd, so I circled them. These 3 have x squareds, so I circled them. These 2 have x's, so I circled them. The only ones I didn't circle were 4x to the 4th because there's no other x to the 4ths, and positive 12 because there's no other coefficient, or there's no other constants. So I'm going to write them out. 4x to the 4th. I'm going to cross it out because I've already used it. You don't have to, but I just kind of do that. Negative 12 plus 7, negative 5. I'm not going to add their powers. Leave their powers alone. So it's going to stay x to the 3rd. So negative 5, x to the 3rd. I'm going to cross them out because I've already used them. The blues, I got to add the blues. 16 plus negative 21 plus 3. That's going to be, let's see, negative 5 plus 3, negative 2. Negative 2x squared. (28 minus 9 is positive 19, positive 19x. And then positive 12. So when we do these problems, we usually put them in what's called descending order. Descending means their powers go down. Power of 4, power of 3, power of 2, power of 1, no power. Okay? It's usually what we do. We do the big powers first and then work our way down. Done. Okay. All right, so we're going to do this last one. If we have time, we'll do one more, but I definitely want to do this one. Okay, so this guy. This guy is one that pops up a lot because it's got a lot of different things going on. Okay, so this guy here is simplify. Simplify the expression and make sure it's in standard form. The answer is in standard form. Okay, so this one has something we haven't seen yet. What does it have that we haven't seen yet? It's got a couple of things we haven't seen yet, but what are the things that we haven't seen yet so far? It's got a squared, right? It's got a squared. We've never seen a squared yet today, outside the parentheses, right? It's also it's a little bigger. It's bigger than we've seen before, right? So this is what we're going to do. We're going to simplify this by using PEMDAS. PEMDAS. Parentheses, exponents, multiplication, division, subtraction, addition, subtraction, all that good stuff. Okay, so the first thing we got to do is parentheses. Inside the parentheses, can I add x plus 4? No. So we do have parentheses, but I can't really do anything with them. Okay? The next thing, exponents. I do have exponents. I have a power of 2. Who gets that 2? Whose squared is that? Who has a power of 2? Yeah, everything in the parentheses. Everything in the parentheses have a 2. So there are parentheses. So I'm going to go take take this guy over here and deal with it because I'll come back to the big problem, but right now I want to deal just with the green. Okay, so I'm going to kind of pull the green away for right now. Oops, not 2, 4. So anything that's squared, what does anything that's squared mean? Times itself, right? So I'm going to rewrite it. X plus 4, x plus 4. How do I multiply those two guys? No. The answer is you've done it twice, 3 times already. Box. How big of a box do I need to multiply these guys? 2 by 2. So let's do it. 2 by 2 box. This has got 2 terms. This has got 2 terms. So I'm going to set up a 2 by 2 box. X plus 4, x plus 4. Okay. So x to the first power times x to the first power, x squared. X times 4 is positive 4x. Another positive 4x and another positive 16. I have 2 like terms, positive 4x and positive 4x. Combine them together. That is the same thing as the original green. They are the same thing. One's just multiplied and one's not. So what I'm going to do is I'm going to move this guy back in. I'm going to move this guy back in because it's the same thing. So x squared plus 8x plus 16. No more parentheses, no more exponent outside the parentheses. Bring everything down I haven't used. So I haven't used the negative 4 parentheses x plus 4 and the plus 6 yet? Okay. How do I get rid of these parentheses over here? Multiply. You just did it before. You guys have done it before. We're going to distribute the negative 4. So this becomes negative 4x minus 16. Bring everything down that we didn't use. Combine like terms. Let's see, we get positive 4x and then positive 6. Done. Positive 8 plus negative 4 is positive 4x. 16 minus 16 is 0. Plus 6 is positive 6. Okay? I want you to do one more problem like this. I'm going to give you one problem like this to do in your notes on page. So go to page 12. Go to page 12. I'll show you where you're going to put it in your notes. Go to page 12 in your notebook. So page 12, wherever you have page 12, you're going to do it underneath where you tape it. Okay, I'll pass out the tape right now, but you're going to do it underneath on the actual paper, underneath where you usually tape it. Okay, that's where you're going to do this problem. So I'll pass out the tape right now, and you're going to do this one right underneath it, so that it's there below your taped in. So this one's going to be example 6. Example 6.
Because you know how we started another one? It's just the same thing, like, right? Just go to the next one?
Yep, go to the next page. Yep.
Same page, people.
Yeah. Yeah, we just keep going to the next page. Yep. Okay, so example number 6. There we go. Okay, here we go. Last problem, and then we're done. So this one is the same directions as number 5. Okay, simplify. Into standard form. Okay. So here we go. 3 parentheses x minus 2 squared minus 5 parentheses x minus 2 plus 3. So actually this one I'm going to do with you guys because this one's a little different. I'm going to do this one with you. If you want to try it on your own, go for it. But I'm going to do this one with you because it's a little different. What's the different part? Does anyone see the different part of it? There's a 3 in the very front, right? We didn't have a 3 in the very front. So can I distribute like that? The answer is no. I can distribute this guy, but why can I not distribute this guy? The power, yeah. The power can't be there. If that power wasn't there, totally go. But I have to handle that power before I distribute. So I can't distribute yet. So what do? I do the same thing I did last time, right? Let's deal with parentheses. Or sorry, exponents. I'm going to make a little side step over here. That means times itself. So I'm going to set up a 2 by 2 box, just like I did the last time. So far, nothing's changed. X squared minus 2x, positive 4. Combine like terms. Move this guy back in. Okay. The difference is, though, it's still going to be in parentheses. When I move it back in, it's still going to be in parentheses. The reason it's still in parentheses is because of that 3 in front. Okay? So now what am I going to do? Yeah, now I can multiply. Now I can multiply the 3 and the negative 5. Because those parentheses don't have a power anymore. So I get 3x squared minus 12x plus 12, and then negative 5x plus 10 plus 3. And then combine like terms. Last thing, combine like terms. The reason I wanted to do another problem like this is because these are the types of problems that always show up on quizzes and tests. So I wanted to give you guys another example of one in your notes. Combine like terms. 3x squared minus 17x plus 25. Done. Okay. All right, so tape that into page 12, and then we'll do some more practice tomorrow with these, okay?